Hi everyone. Today we are going to talk about something that brings AI one step closer to the reality. Have you ever wished your AI could actually do things for you, not just give you advice or instruction and responses? Just like Jarvis, Tonics our autonomous AI assistant that takes his commands and executes the task independently. Meet OpenClaw, an open source autonomous AI agent that run locally on your computer or machine and execute the real world task for you. It's not just going to chat with you, but also going to take some action and act accordingly. Originally launched in November 2025, it was firstly called as Claude, briefly rebranded to MoltBot. Due to the trademark issues and name similarities, it is finally renamed as OpenClaw. But the core idea has never changed, giving the AI the power to act independently. So how it works or what it can do for you. Imagine an AI assistant that lives on your computer, Mac, Windows or Linux, running AI model locally or via OpenAI or Anthropic while keeping your data private. You can interact with it through any chat app, WhatsApp, Telegram, Discord, Slack, Signal or iMessage. And thanks to its persistent memory, it remembers your preference and context and become truly yours. It can browse website, fill forms, extract data, manage file, run script and execute commands all under your control. You can choose whether it has full system access or operate in a safe mode like sandbox mode. It can also extend its ability with community plugins or skills, or even you let the OpenClaw to create its own skills. It constantly learn new abilities, act as a personal assistant that think, act and adopt for you. It is designed to act not just for chat. Thanks to its persistent memory and proactive responses via any chat app, it can handle real-world tasks across many areas. For personal productivity, it can draft and send emails, manage calendars, and resolve scheduling conflicts. For traveling purposes, it can find and book the flights, check you in, and manage boarding passes. In automation area, it can extract data, fill forms, monitor processes, and send alerts. In business area, it can automate the customer supports, monitor system, and act as a persistent virtual assistant who never sleeps or forget and always get the things done. Imagine texting, book me a flight to London next week, and check me in 24 hours before departure. OpenClaw can make it happen proactively and automatically. Before we deep dive into the architecture, let's understand the key difference between the chatbot like ChatGPT or Claude and OpenClaw agent. A standard chatbot lives in the browser, forgets everything when the session ends, can write code, acts reactively by waiting for you to type, and can only tell you how to do something like book a flight or check in. OpenClaw, on the other hand, runs on your computer or machines, remembers your context and preferences in the persistent memory, can execute code, run apps, move files, and act proactively, even waking up to message you first. For example, when you provide your traveling details and preferences via your chat app, OpenClaw will automatically use them to book your flight and even check you in before departure. By opening your browser, navigating to the airline website, filling in the passenger details, handling the pop-ups, downloading the boarding passes, saving them locally, and notifying you on your chat app. No copy paste, no hand holding, everything happens automatically according to your preference. Now we will be going to discuss the high level architecture diagram. The first layer is the interface and the input layer. Message enter the OpenClaw as a raw instruction through WhatsApp, Telegram, Discord, Slack, or the terminal CLI. In addition to the chat messages, OpenClaw also accepts the non-chat inputs such as heartbeats, cron jobs, hooks, and webhooks. Heartbeats and cron jobs turn times into the inputs, trigger schedule checks or actions without the agent deciding anything. Hooks respond to the internal system events like task completion or memory updates, while the webhooks allow external events such as emails, calendar alerts, or GitHub issues to trigger the actions. This layer only collects the raw instructions as an input from any source and passes it to the second layer, which is the gateway control panel. The gateway control panel runs locally on a dedicated port. This layer organizes the incoming inputs to ensure the stability and the correctness. Channel adapter normalizes all messages into the single internal format. The session router isolates the private and the group conversation so that the context never mixed. The lane queue serializes the task, ensuring multiple requests are handled safely and in order to prevent crashes or conflicts. This layer enforces order isolation safety before any intelligence is applied on third layer, which is the agent runner. The agent runner acts as a brain and decide how a task should be handled. The model resolver selects the appropriate AI model such as Llama, OpenAI, or Anthropic. The context window guards manage the limited model context by summarizing and trimming the old data to avoid failure or excessive cost of AI model. The system prompt builder constructs the precise instruction with roles, relevant context, and tools permission. This layer plans and reasons but do not execute actions directly. After including preferences in the prompt as a context, it communicates with the layer 5, which is the hybrid system model, and act as a persistent memory. It contains the JSON log files that stores the complete history of your interactions. Memory.md file holds the created facts such as the references, system details, and the server IPs. A vector FTS5 indexing enables the semantic search, allowing the agents to recall the relevant information from weeks ago. This layer ensures the OpenClaw remains persistent and personalized. So after including the required preferences from memory into the system prompt builder, it comes to the layer 4, which is the execution and tools and act as a hands. Here the planned actions are executed safely. Prompts are sent via LLM API call to Claude, OpenAI, or local Llama models. All actions runs inside the sandbox environment to prevent the accidental system damages. Available tool include shells, which can run terminal commands, for example, checking the logs and get commits. Headless browser, like Puppeteer, can automate the website, click buttons, and scrap the data, and providing the full system access to read, edit, and create new files or documents. And finally, the output of this layer is sent back to you via layer 2 and deliver the result on your phone via your chat app. So to summarize the overall architecture, the layer 1 collects the input, layer 2 normalize, isolate, and queue it, layer 3 plans a task and consult with layer 5 for memory, and layer 4 execute the shell commands safely. Next, we discuss the security and risk around autonomous AI agent like OpenClaw. Because these agents have deep system access, a single vulnerability can fully compromise the system. We have already seen misconfigured setup exposing control panels and conditions, malicious third-party skills with files of network access, and even the fake VS Code extension impersonating OpenClaw that contains malware. Similar to the social AI agent network MoltBot, it has also some security risks, and that's why we need to follow the best practices which are not negotiable. For example, run the agent in a shared machine or virtual machines, audit every skills before installing it, avoid exposing port to the public internet, rotate API keys regularly, and keep all the agents software fully updated. Although the OpenClaw is open source, but running it is not free. You need hardware or a cloud server, often running 24/7. If you use the LLMs like ChatGPT, Claude, or Gemini, API usage can become expensive. Each agent loops involve multiple API calls, code generation, error fixing, and retries. A task that gets stuck overnight can burn around $50 to $100 or even more. This is not the fire and forget automation. It demands budget limit, monitoring, maintenance, update, backup, and security audits. Early users have already reported shockingly high cost when running the large models without constraints. And finally, we will discuss what does it mean for future. AI agents are evolving into the autonomous sector that can coordinate tasks, execute workflow, and make decisions, blurring the line between tool and digital assistant. This forces a major shift in the cybersecurity because the traditional model assumes human in control, not the autonomous system. At the same time, the agent-only social network like Workbook raises deep questions about digital culture, awareness, and whether the AI system can stimulate the social behavior at scale. And finally, the workforce will change. Digital assistant handling scheduling, research, support, and automation will redefine the boundaries not limited to humans but reshape how work gets done. So that's it for today's AI update. If you have any opinion or experience to share, write them in the comment section. And if you like this video, then hit the like and subscribe button and share it with others as well. Thank you for watching.